Chapter 1 Matter. For first week of lecture, we are going to cover subtopic 1.1 and maybe half 1.2. So in this chapter, there are 3 subtopics. For first subtopic, atoms and molecules, we are going to learn how to write isotopic notation, interpret mass spectrum, and calculate the average atomic mass of an element. Matter is anything around us, and the smallest part in an element called as atom. Atom from the Greek words meaning cannot be divided anymore. So now let's take a look at how the atomic structure looks like. It consists of nucleus in the middle and surrounded by electrons. And in the nucleus consists of proton and neutron. The particles in the nucleus called as nucleons. The particles have their own charge and mass. Look at here. Proton with charge positive, neutrons no charge, electrons with charge negative. If we compare the mass between proton, neutrons and electrons, which one has the lightest weight? Yes, electrons have the lightest weight. So, for the mass of an atom, we just consider for the mass of protons and neutrons. The unit for mass of atom is U or AMU, which is atomic mass unit. We use symbol to describe the particles. For example, capital Z to describe proton number, capital A to describe nucleon number. So, capital Z is number of proton in the nucleus, also called as atomic number. Capital A, nucleon number, also called as mass number, consists of proton numbers and neutron numbers. We use isotopic notation to describe subatomic particles in an atom. It is atomic symbol. Capital X represent element of an atom. A for nucleon number written at left and upper side. Capital Z represent proton number written at lower and left side. You can get this value from a periodic table. For example, isotopic notation for aluminium atom. Atomic mass of aluminium, or called as nucleon number, is 27, written at left and upper side. Proton number for aluminium is 13, written at left and lower side. From this information, we can identify the number of neutron is 14. Isotopic notation for ion, the charge is written at right and upper side. For a neutral atom, number of proton is equal to number of electron. When 3 electrons been removed, the remaining electrons is 10. So, positive charge to show electrons been removed and negative charge electron been received. Only the number of electrons change when it form positive charge or negative charge. The number of proton and neutrons in the middle not affected. For example, isotopic notation of neutral mercury and copper, total of proton number and neutron number is nucleon number, so written at upper left side. Proton number written at lower left side of the element. Since there are neutral atoms, so number of electrons is equal to number of proton. Next, for oxygen with negative charge, total number of proton and neutron is nucleon number, written at upper left side, and proton number at lower left side. In neutral atom, oxygen has 8 electrons. Since it received 2 electrons, the number of electrons become 10. For cobalt with positive charge, total proton and neutron number is nucleon number written at upper left side, proton number at lower left side. In neutral cobalt atom, number of proton is equal to number of electron. Since it is with positive charge, meaning 3 electrons being removed. So the number of electrons left is 24. Next, isotope. Isotope is two or more atoms that have same proton number but different neutron numbers. So these contribute to different nucleon number. So most of the elements do not have same mass but still have same proton number. For example, isotope of hydrogen, they have same proton number 1 but different neutron numbers. So mass spectrometer is an equipment to determine the type of isotope found and to get relative atomic mass of an element. For example, we want to check the sample of soil. Then we put the sample here. After ions accelerated, then it will give this reading. And this mass spectrum you can see on the monitor screen that connected to the mass spectrometer. Next, how to interpret the mass spectrum from the mass spectrometer. In mass spectrum, y-axis to indicate relative abundance. So relative abundance will be given either in ratio, percentage, or fraction. X-axis indicate different mass for an element that have isotope. The height of the line indicates the abundance of each isotope. So, for this isotope of magnesium, it shows that abundance of magnesium with mass 24 is the highest. Next, isotope of carbon. There are 3 isotopes of carbon, but the carbon with mass of 12 is the highest abundance. Since all of the elements do not have specific atomic mass, so in periodic table, the mass stated for each element is based on average atomic mass. How to calculate average atomic mass? The mass of each isotope multiplied with its abundance, either given in percentage, fraction, or ratio, divided to total of abundance. The unit for average atomic mass is U. For example, to calculate average atomic mass of carbon, given isotopic mass and abundance for each isotope in percentage. So, to get average atomic mass of carbon, total of abundance of each isotope multiply with its isotopic mass divided to total of abundance. Next, to calculate average atomic mass of magnesium given by mass spectrum, total abundance of each isotope multiply with its mass divided to total of abundance. In order to relate atomic mass with standard measurement, carbon-12 isotope been chosen as the standard atom. According to the unified atomic mass unit, U is defined as 1/12 of the mass of the carbon-12 atom, meaning for mass of one carbon-12 atom is 12 U, and mass of one carbon-12 atom in gram is 1.992 exponent negative 23. So, for 1/12 of carbon-12, we can get 1 U, and 1/12 of mass atom in gram, we can get 1.67 exponent negative 24 grams. Relative mass, either for atomic mass or molecular mass. The relative atomic mass with symbol capital A lowercase r is the average mass of one atom of element compared to 1 of 12 from mass of one atom carbon-12. The value with no unit because it's been cancel each other out. For example, to calculate relative atomic mass of gallium, for the two isotopes of gallium, abundance given in percentage and isotopic mass in U. So, firstly, we calculate the average atomic mass, then we compare to 1 of 12 from mass of one atom of carbon-12. So, the value of relative atomic mass is applicable for the elements in periodic table. For the relative molecular mass with symbol capital M lowercase r, it is average mass of one molecule compared to 1 of 12 from mass of one carbon-12. Value also do not have unit. It is the sum of relative atomic mass of all the atoms in the molecules. For example, to calculate the relative molecular mass of carbon dioxide, so we total the relative atomic mass of carbon and relative atomic mass of oxygen molecules. So, the value of relative molecular mass of carbon dioxide with no unit